Exercise 7.3, question number 9. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated if first part, 4 letters are used at a time. Second part, all letters are used at a time. Third part, all letters are used but first letter is a vowel. So let us start doing this question number 9. So solution of question number 9. The word which we are having is Monday. So how many letters are there in the word Monday which are distinct? 1, 2, 3, 4, 5, 6. So there are 6 distinct letters. So that is what we'll write in the word Monday. In the word Monday, number of distinct letters. Number of distinct letters equal to, just count it, 1, 2, 3, 4, 5, 6. So they are 6. Now let us do one by one all the parts of this question number 9. First one, 4 letters are used at a time. 4 letters are used at a time. That means we have to fill up 4 places. So here first of all let us write here, therefore n equal to 6. Therefore r equal to 4. So therefore what we can get, required 4 letters are used at a time, therefore r equal to 4. Therefore number of words which can be formed assuming that no letter is repeated. Assuming that no letter is repeated. Assuming that no letter is repeated, and what is the case? 4 letters are used at a time. When 4 letters are used at a time, 4 letters are used at a time, and that is nothing but out of 6 we have to use 4 letters, so that will be 6p4. So that is equal to 6p4, and simplifying it, we will get 6 factorial over 6 minus 4 factorial, that is 2 factorial, and this will give us equal to 6 into 5 into 4 into 3 into 2 factorial over 2 factorial. So both being cancelled out, and let's simplify this. 5 into 4 is 20, 20 into 3 is 60, and 60 into 6 is 360. So there are 360 ways in which we can write words containing 4 letters at a time from the word Monday. So this is answer of question number 9th, first part. Now let us go in the second part of this. So second part, all letters are used at a time. All letters are used at a time. Are used at a time. Therefore here n equal to 6. Also number of places to be filled up are 6. So r equal to 6. Therefore required number of words equal to, that will be 6p6, and that is equal to 6 factorial over 6 minus 6, that is 0 factorial. So it will be equal to 6 into 5 into 4 into 3 into 2 into 1 equal to 3 into 2 6, 6 into 4 is 24, 24 into 5 is 120, 120 into 6 is 720. So answer this will be 720. So this is the answer of the second part. Now let us do the third part. The third part, what we have to prove, that all letters are used, but first letter is a vowel. So how many places are there to be filled up? There are 6 places to be filled up. So doing the third part, so let the places to be filled up be, let the places to be filled up be 1, 2, 3, 4, 5, 6, there's 6. There is x1, x2, x3, x4, x5, x6. Now it says that all letters are to be used, but first letter is a vowel. So the first one, that is x1, has to be a vowel. So in Monday, in the word Monday, in the word Monday, there are two vowels. There are two vowels, that is A and O. So there are two vowels. Therefore, required number of words, required number of words is equal to, first of all we will fill x1, that can fill up in two ways, into, now we are having 5 places to be filled up, and there are also 5 letters, so 2 into p 5p5, and that is equal to 2 into 5 factorial, and we know that 5 factorial is equal to 120. So or you can just calculate it, 2 into 5 into 4 into 3 into 2 into 1. So what you will be getting here, 3 into 2 is 6, 6 into 4 is 24, 24 into 5 is 120, 122 is 240. So the answer of the third part is 240. Exercise 7.3, question number 10. In how many ways of the distinct permutation of the letters in Mississippi do the 4 I's not come together? So to solve this one, what we'll do is we'll first find all the words which are possible with the letters of the word Mississippi, and from that we'll subtract the case when all the 4 I's come together. We'll subtract those words in which all the 4 I's come together, and we'll get our answer. So let us start doing question number 10. So solving 10th one, solution 10. In the word Mississippi, MISSI, then again we are having double S I double P I. Now let us count all the letters of the word Mississippi. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here n equal to 11, though all are not distinct, and in this we'll see that which letters are being repeated. So M is not being repeated, I is coming how many times? 3 times. Then S is coming 4 times. I is coming actually 4 times, so let's do the correction here. I is coming 4 times. Then P is coming 2 times. So if we add them, we'll get 4 plus 4, 8, 8 plus 2, 10, and one letter is there here, M, is being coming only one time, so that is 11. So now what we'll do is that here we have to find all those words in which the 4 I's do not come together. So first we'll take the case when all the 4 I's are coming together. So and let us make one block of these I's. let the four eyes let the four eyes let the four eye make a block. I so this was single block, and now there are other than I, how many letters are there when we count them being repeated and all that? So that is 4 plus 2 6, 6 plus 1 7. So now because we have considered this 4 eyes as one block, so and the remaining letters will be remaining letters is equal to, they are 4s plus 2p plus 1m is there, that is 7. So equal to 7, and this one block of I that is equal to 1. So total n which we are getting here, therefore n equal to in this case will be 7 plus 1 equal to 8. Now we want to find so this is 8. So the number of words, therefore number of words which are formed when all the four eyes are together, when all the four eyes are together, that is equal to. So here we have seen that if you move back, we see that I is being repeated, S is being repeated, P is being repeated, but I we have taken as one single block. So in this 8 we can see that P and S are being repeated. So what we'll do is, now the number of words which can be formed is equal to 8 factorial over, so which letters are being repeated? The letters which are being repeated are S and P. S is coming 4 times, P is coming 2 times, so we'll divide by 4 factorial and 2 factorial. We'll divide 8 factorial by 4 factorial and 2 factorial. So this will give us equal to 8 into 7 into 6 into 5 into 4 factorial over 4 factorial into 2. 2 factorial is 2 into 1, that is 2 only. 4 factorial 4 will cancel out. Then here we can cancel out 2 and 6. So that will become 3. So equal to 7 into 3 is 21, 21 into 5. That is 105, and 105 into 8. So that will give us 8 5 is a 40, 4 carried over, 8 0 is 0. So it will become 4 here, we get 8. So that is 840. Now next what we'll do is we'll find all the letters, all the words which can be formed by the letters of the word Mississippi, and from that we'll subtract this 840, and then we'll get the required answer. So let's start doing that one. So number of words which can be formed using all the letters of the given word, of the word MI double SI double SI double PI, 1 2 3 4 5 6 7 8 9 10 11. So here n equal to 11, and we have already seen that m is coming only one time, then I is coming 4 times, S is also coming 4 times, and P is coming 2 times. We add them, we'll get 8 plus 2 10, 10 plus 1 11. So the number of words which are possible, therefore number of words possible are equal to 11 factorial over 4 factorial into 4 factorial into 2 factorial. This will give us equal to 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial over 4 factorial into 4 into 3 into 2 into 1 into 2 into 1. So this is what we have got, 11 factorial over 4 factorial into 4 factorial into 2 factorial. So cancelling 4 factorial and 4 factorial, and then 3 and 2 together will become 6. So this will cancel the 6, and 4 and 2, that will become together 8. So it will cancel this 8, and what we'll be getting is here 7 into 5 is 35. 35 into 7 into 5 will be 35. 35 into 9 into 11, that is 99. So this will give us 9 into 5, 45, 4 carried over, 9 to 3, 27, 27 plus 4, that is 31. So here also 3, 1, 5, this is 5, this is 6, this is 4, this is 3, and 1 10 is here, so this will become 3, 4, 6, 5, 0. So these are the total number of words which can be found by using all the letters of the word Mississippi. Now to get our answer, what we'll do is, from this we'll subtract the case when we have taken all the 4 i's together. So that is what we'll do. So let us go in the next stage, that is the number of words in which all the 4 i's do not come together. So that is equal to we'll first take all the words which are possible by using the letters of the word. So what is our word? That is Mississippi, Mississippi, minus, from this we will subtract when all the 4 i's, from this we subtract all the words in which all the 4 i's come together. So minus all the words in which 4 i's come together. So that is equal to, so the all words which are possible by using the letters of the word Mississippi are, already we have got here, that is 34650. So that is equal to 34650 minus now all the words in which 4 i's come together, and they are here, that is 840, number of words which are found when all the 4 i's are together. So minus 840, and let us do the subtraction here. 34650 minus 840, so 0 and 0, 5 minus 4 is 1, then 16 minus 8, so that will give us 8, and this will become 3, and here we will get 3. So the answer is 338100. So this is the required answer of question number 10. Exercise 7.3, question number 11. In how many ways can the letters of the word permutations be arranged if The first one, words start with P and end with S. Second, vowels are all together. Third one, there are always 4 letters between P and S. So let's start question number 11th. Solving question number 11. So the word which we are having is permutations. So in the word permutations, permutations, let us see how many letters are there. So here n equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is 12 here, and let us see if any letter is being repeated. So we can see that T is coming 2 times. Only T is coming 2 times. T comes 2 times. T comes 2 times, and all other letters come only one time. Come only one time. And let us see what the letters are. They are P. So that is what we write here. The letters are P. Here we are having question number 11, second part. Vowels are all together. So let us separate the vowels and the consonants. So P, then we are having R, then we have M, then T, then we have N, and we have S. So these are the consonants, and vowels will be E, O, U, I, and total this would be 12 in number. So let us check it out. They are total 12 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 only, and A, U, A, I, O. So A is also there. We will write A here. So now, because A is a vowel, so this is a vowel, and these are consonants. Why we are writing that? Because we'll need them for second part. So now let us count out the letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now our separation of consonant vowel is correct. So now we'll do the first part. We'll go in the first part. So what is the first part here? Words start with P and end with S. And what is the value of N? We have seen that N is 12. So that means you have to fill up 12 places. Let the position of the letters of the word, let the position of the letters to be fixed. B, and this will be common for all, to be fixed. Let the position of the letters to be fixed be x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, x11, and x12. So this is what we are getting. So x1 till x12, and now we can start one by one all the parts. So we'll be doing the first part. First part is words start with P and end with S. Words start with P and they end up with S. With P and end with S. So that means the position of P and S is fixed. So number of ways in P and S can be arranged is only one, because P has to be at x1 and S has to be at x12. So number of ways, therefore number of ways in which P and S can be arranged, in which P and S can be arranged, that is equal to how much? Only 1, because we have definitely to put P at x1 and S is to be put up at x12. So the position is fixed. And now remaining, how many letters we are having? 12, and that we have to arrange between x2 and x11. So that means we have to fill up 10 places, and we have seen also, we move back, out of these two letters, that is T is coming 2 times. So we'll take that also under consideration. So we write the answer of first part. Therefore, number of words which can be formed is equal to, and what is that? 1 into, in between there are 10 positions that can fill up in 10 factorial ways, divide by, because T is coming 2 times, so 2 factorial. So that is, final answer will be 10 factorial over 2 factorial, and we can simplify it. So let us do the simplification of this one. So equal to 10 factorial over 2 factorial. This will give us equal to 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial over 2 factorial. So cancelling 2 factorial both in the numerator and denominator, equal to, now first let us solve. 10 will keep intact as it is, so 9 into 8 is 72. So 10 into 72 into 7 into 6 is 42. Then 5 into 4 is 20, 20 into 3 is 60 into 60. So this will give us, then we will multiply 10 and 60, it will become 600 into 72 into 42. So let us multiply 72 and 42. This is 72. So we'll get 2 into 2, 4, 7 into 2, 14. Then 4 into 2, 8, 7 into 4 is 28. Adding these are 4, 8 plus 4 is 12, 1 carried over, 9, 10, 1 carried over, that is 3024. So what we are getting here is 600 into 3024, and this will give us equal to 0, 0. Then 6 into 4 is 24, 2 carried over, 6 into 2, 12, 14, 1 carried over, 6 into 0 is 0. So 1 carried over from the earlier one, and 6 into 3 is 18. So this is the answer of the first part, 1814400. Now let us do the second part. So second part, all letters, vowels are all together. So vowels are all together. Vowels are all together. Second part solution. And we have seen initially that, let us go back in the beginning. So there are 5 vowels. How many vowels are there? These are total 1, 2, 3, 4, 5. 5 vowels, and consonants are 1, 2, 3, 4, 5, 6, 7. 7 consonants. Consonants are 7. So vowels are all together. That means vowels should be always together. So let us first consider the vowel as one block. Consider the 5 vowels as one block. Consider the 5 vowels as one block. So this is the vowel. This is all, we are, for time being we are considering only one block, and consonants are, how many consonants are there? And there are 8 consonants. Sorry, let's move back and see. There are 7 consonants, and there are 7 consonants, and there are 7 consonants. Therefore, now this is one vowel. This vowel block is one, and there are 7 consonants. So, in total, we have to fill up how many places? 8 places. Therefore, number of places to be filled up. Number of places to be filled up. To be filled up is equal to 1 plus 7, that is 8 factorial. But in this block of vowel, we can how many vowels are there? 5 vowels. We can arrange them in how many ways? 5 factorial ways. Also, in the block of vowel, in the block of vowel, there are 5 vowels. Therefore, the vowels inside the block, the vowels inside the block, inside the block, inside the block can be arranged in how many ways? In 5 factorial ways. Therefore, number of ways in which words can be formed, in which vowels are always together, are always together, that is equal to 5 factorial into, and how many consonants are there? See here, we have taken this as one vowel, and the places we have taken is 8 places. So 5 factorial into, this will not be 7 factorial, into 8 factorial, because 7 we are having 7 consonants plus one block of vowels. So total there are 8 positions to be filled up. So 8 factorial, and in this also we know that what we know is in this 7 consonants, if we see back from the beginning, the consonant T is being repeated 2 times, so we'll have to divide with 2. So divide by 2 factorial. So this will be our required answer, and let's simplify this one. So we'll be getting equal to 5 into 4 into 3 into 2 factorial into now 8 factorial, that is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 over 2 factorial. So this is what we have, 5 factorial into 8 factorial over 2 factorial. So 2 factorial and 2 factorial cancel out, equal to 5 into 4 is 20, 20 into 3 is 60. So equal to 60 into, now let us do the multiplication of this one. So what we are getting here is 5 into 4 is 20, 20 into 3 is 60, 60 into 2 is 120, 120 into 6 is 720. So 720 multiplied by 7 into 8, that is 56. So just we'll take this 0 later on. So multiplying 72 and 56, 6 into 2, 12, 1 carried over, 7 into 6, 42, that is 43, and 5 into 10, 1 carried over, 7 into 5, 35, 36. So this will become 2, 3 and 10, and 1 carried over, 4032. This is 4032, and this 0 is there, so 0 equal to 0, 0. 6 into 2 is 12, 1 carried over, 6 into 3 is 18, that is 19, then 1 carried over, 6 into 4 is 24. So the required answer is equal to 241920. So this is the answer of the second part. Now let us go in the third part. There are always 4 letters between P and S. There are always 4 letters between P and S. So let us we'll make a diagrammatic view of this one. X1, X2, X3, X4, X5, X6, X7, X8, X9, X10, X11 and X12. So what it says that there are always 4 letters between P and S. Suppose P is at X1, P is at X1, then in that case S will be automatically, because between P and S there should be 4 letters. So where will be S? S will be at 1, 2, 3, 4. That is, it's here 4 letters should be between that, X2, X3, X4, X5. So it has to be at X6. If P is at X1, S has to be at X6. So suppose P is at X1, then S is at X6. Similarly, if P is at X2, then S is at X7. And same way we can see here the S can occupy place X6, X7, X8, X9, X10, X11, X12. How many ways are there? 1, 2, 3, 4, 5, 6, 7. So same way, if P is at, then P will be at X7. P is at X7, then S is at X12, because in between them there should be 4 letters, 1, 2, 3, 4. So this can be done in how many ways? It can be done in 7 ways. Clearly this can be done in 7 ways. Clearly this can be done in 7 ways. Can be done in 7 ways. But it is possible that instead of P, S is at X1, that is P and S can interchange. Also P and S can interchange in 2 ways. Also P and S can interchange their position in 2 ways. P and S can interchange their position in 2 ways. Therefore, number of words possible that is equal to 7 into 2. 7 for when P is coming first and S is coming later, and 2 for being interchanged into. Now in between that, because we have right now fill up only 2 positions, and in between that there are 10 letters, 10 positions to be filled up. So that is 10 factorial, and in those 10 letters T is coming 2 times, so we will divide this with 2 factorial. So this is the answer of third part. Let's simplify it. So it will become 7 into 2 into 10 factorial will become 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 over 2 factorial. 2 factorial means 2 into 1. So 2 factorial and 2 cancel out, and equal to, we will be getting 7 into, remaining is we can see from here, remaining will multiply, that is from 10 till 1. So equal to 7 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And in this we can take the earlier calculations. We have done some calculations earlier also. If we see it here, let us see if we can use any one of them. 8 factorial is there, but do we have the value of 8 factorial? If not, simply we can put the values. So 7 into, now let us multiply them. 3 into 2, 6, 6 into 4, 24, 24 into 5 is 120, 120 into 6 is 720. So this is 720. And 7 into 8 is 56. And 10 into 9 is 90. So 7 into 90 into 7 into 8 is 56. Into, and what we got for this? 3 into 2, 6, 6 into 4, 24, 24 into 5 is 120, 120 into 6 is 720. This is what we have got. Now let us multiply all of them. So we'll first multiply 72 and 56. I think the multiplication of this already we are having earlier. 72 and 56, that is 4032. So that we can use here, or you can multiply again. So 7 into 90 into, that is 4032. 40320. 56 into 72, if you can if you want, you can multiply again, but that will be 4032, and this 0 is there. And 7 into 9 is 63. So 63 into, what we will be getting here, 4032, and this 0 we can take here, 0 0. So let us multiply 4032 with 63. 4032 into 63, this will give us 3 into 2 6, 3 into 3 9, this is 0, 4 3 is 12. Then 6 into 2 12, 1 carried over, 6 into 3 18, 19, 1 carried over. Then 6 0 is 0, so 1 will come here, and 6 into 4 is 24. So this will give us 6, 9 plus 2 is 11, 1 carried over, this will become 10, 1 carried over, so it will become 4, 3 plus 1 4, this is 5, and this is 2. So what we are going to get is 254016, and these two zeros are there. So this is the answer of question number 11, third part, and with this exercise 7.3 is also complete.